All right, let's do this. Number 5 from yesterday. If you don't get your, that's what I'm looking for, calculators. You won't go ahead and get your calculators out. We will need those for our notes today as well. So on number 5 here, um, on number 5, as we look at this one, keyword is bisect. Okay, keyword is bisect in number 5, and as we've talked about vocabulary over the last month or so, bisect means in the middle, cut it in half. All right. So cut it in half. Those two, that larger angle again got cut into half, two equal angles. So that 7x minus 7 is equal to 5x plus 3. So that's gonna start off here, and then with that, for me, then we can tell we made a typo. So 7x, subtract that 5x is 2x. 7 plus 3 should be what? 10. And 10 divided by 2 is 5. X is not 6, but that should have been a 5 there. Jillian and Eva, I'm guessing that's yours trying to call me out on that one? Yeah. Okay. So bring that up as I'm talking to you guys so I can make those fixes as we go through and work. Okay. All right. Let's keep talking here. Other things that anybody's got. Yes, Brianna. Okay. 3's sure. Let's take a look at 3 up above. Wrong button. All right, number 3 right there. First thing we look at 3 then is listing out from orders as we talked about. Now on that one, shortest to longest side. Now, thing that jumped out to me on that one is I don't have the measured angle C. So as we've worked through here, we're going to get into some of that today with triangles. But the thing about the measured angle C is, can I take your homework there, bud? Yeah. So go find that measured angle C. All right, so that you can know how does angle C fit into the other two angles up there. So on that angle C, 82, 62, and we know that there are 180 degrees in the triangle. 82 and 62, right? So angle C should be 36 degrees. Now once we have that out there, now we can listen out from shortest to longest. So that relationship is the smallest angle is opposite the shortest side. So I'm looking at the smallest angle to start off with, and that smallest angle is angle C. So if I'm standing at angle C, the other two vertices, the adjacent vertices, the adjacent vertices, which in this case is what? D and E, is making up that opposite side. So that's why I said DE is that. So angle C is only 36 degrees. It's making that shortest side. And then the next one, the medium one, is angle E, which is 62 degrees. So now pretend you're standing at angle E, and as you stand at angle E, look at the two vertices on your kind of left and right. Well, you notice that from angle E, you're looking at what? C and D. C and D make that side. And then what? D is the last one. It's the largest angle. It's the longest side. D, you're standing angle D now. And what are your two opposite? The two opposite, your opposite side. That's the two vertices then. C and E. But if you don't have that third angle, 180 degrees, subtract out these two that you know. Okay. All right. Anything else anybody's got? Good questions there. Anybody else? Yeah, oh, sorry, Kaden, what you got? Which one was it? 10. 10? All right, let's look at 10, guys. Okay, going back a little bit longer ago from the circle vocabulary that we've done. This morning I was looking for your test for next week, and the circle vocabulary will definitely be on there. So however you want to draw that picture, it's totally kind of your call. Yours and I's will look differently. But make sure then whenever you finish up that picture, it does match what is there. So creating that circle based off that vocabulary. So here's the picture that I've got going on there. You've got obviously the center O that starts it off, and a radius OA. All right, OA, O is the center, A's got to be on the circle. A I put right there on that circle. Diameter, CD. With that diameter CD, A is already been used. C and D are two brand new points. So I just went ahead and threw C and D on there. And because it's a diameter, what's it got to do? It's got to go through the center, right? So now, from there, we got a chord, AD. Now we talked about a chord is a segment. And on that chord segment AD, we already had A and D on there. So wherever you put A and D on there, connect them out. All right, connect them out. That's making a chord AD. And a chord is a segment inside the circle. Now a secant CB. Now the secant is one of the brand new ones that so you probably never talked about at all until walking in here a month or so ago. And the secant is a line, and it's a line that comes in through that circle, and it intersects the circle at 2 points. So it goes right through that circle at 2 locations. In this case, I'm saying it goes through at C and at B. We already had C in there. Wherever you want to put B going through that circle, fine by me. But B is the new location that we've created. C and B, and I drew mine like that, and it's a line. A secant's a line, so that's why I use my line symbol right there for the secant. And the last one is tangent. I said tangent could be one of 3 things. It could be what? A line, a segment, or a ray. It could be either one of those 3 things. In this case, I said it should be a line, AF. And the tangent here, AF, we already had the A. So as you draw that tangent, make sure it looks like it's somewhat just touching the circle at one point. It's not coming through like a secant is. Now that A, one more time, what do we call that A when it touches that circle there? A is the point of tangency, right? And because it's A is part of the radius, we've talked about that before. We don't have to add that in. I'm just saying because it's intersecting the radius, OA, it does happen to be perpendicular right there, okay? Because it's a radius, it intersects at a right angle, okay? All right, good questions off that. Those are good review questions as well coming up for the tests next week. All right, we got a bunch of triangles to do today. So let's make sure your names are on that. Throw in the baskets, pencils out, calculators out, and we got a bunch. All right, we've already said 180 degrees in triangle. Let's jump right into this because we got a lot to talk about in those 2 pages. Take number 1 right there and go find me out A, B, and C. Okay? Go find me out the measures of angles A, B, and C. All right, take a quick minute and go find me out the measures of A, B, and C. Okay? Anybody else need a whole bunch? Now, finding the measures of angles are still today. All right, what do we got? Somebody got me a measure up there? Somebody got me a measure up there? You got me nothing? You got me nothing. Anybody got me something? C is 20. We think? Yeah, I think C is 20. How did you get C is 20 there, Eva?
Because it's 90 degrees and 90 minus 70.
Yeah, it's a complementary angle with 70 degrees, right? There's my 90 degrees hiding right there. We have that one angle is 70 and the other angle has got to be 20. So once you find one angle, do your best to kind of squeeze it into the picture. Label that out. There's one angle. What's somebody else got for another measure up there? Somebody else got me another measure up there. What's that answer? You get your calculator out. All right. Jillian? A is 70. All right, I agree with you on that one. Eva helped us out. This is 20, and this is 90 here. So what does this do? That makes 90 there, right? So we got an itty bitty triangle on the left there, 180 degrees in a triangle. And because that 90 we just found, and because that 20 that Eva found, what remains out of that, those two angles? 70 degrees remains. So A is going to be, not that, A is going to be 70 degrees. That sounds good. We got one more. What's that one more angle, somebody? Julian? Oh, sorry. Yeah, it's going to be 20. Did you get that there? Okay, I'm hoping it's 20 as well. So on that right triangle, right here, one more time, 100 degrees in a triangle. We got 90 right there. We got 70 right there. 180 minus 90 minus 70. There's my 20. Okay? All right, kind of using that same idea. I'll put a minute on my clock. I want you to go try that next one. Do that same. With x being 50 there, we've got that one locked in. Okay, going through finding y and z. Y could have been probably the next one that's relatively quick. All right. Anybody get me y? James?
30.
30? How'd you get 30 on that, James?
I just add up the angles.
Okay, what angles are you talking about?
So I added x 40 and 60 and got 150. So
Okay. Yeah. So James is saying he looked, and maybe that includes their back there, the whole group. That big triangle?
Yeah.
Yeah. So that y is working with that big triangle, which is a right triangle, isn't it? So if we just take that big triangle off to the side, not quite a right triangle, but it works. 90, 60, and y. Okay. That's a pretty straightforward triangle then, isn't it? So we've talked about this before, like how many triangles do you see there? We want to look at that where there's how many triangles up there? 3 triangles, I think. Okay, we've got one big triangle up there, and then that's 30 degrees, right? Okay, so y is 30. We've got that locked in. So I would, again, always do your best to find it and then write it into your picture. All right, somebody find me z. Jillian?
I have
65. I heard a 65 up here. Jillian, how'd you find me at 65?
I thought there was a 80 in the triangle and then I started 180 minus 80 and 2
Okay, so several different ways, but definitely use that 180 degrees, right? So there's a few different ways, and I know in years past I've found it a couple different ways too. So one way is we found that 30 right here, and inside a triangle is 180 degrees. These 3 angles are adding up to, again, 180 degrees. So 2z, taking your calculator, and negative 30 plus 30 is canceling out, right? Plus 50 gives you 180. So you could go and solve it out and get that 65 like that, okay? Now I know another way, 40 and 60 are making, again, 100, right? And this angle is 80 degrees here. And what do I have right here for these 2 angles? Supplementary, they're a linear pair. That's another route. So there's at least 2 quick ways right there of finding that z. And however you find it, I don't really care. It's just another way to find it out. Okay? Okay, if we have time, we'll come back around on number 3. It's a good one to talk about, but it's not a huge one right now if we got time. All right, so now what I want you to do here is I'm going to put a couple minutes on my clock, and I would like you using your buddy. Try to go through and give me some like definitions. Nothing fancy. You can just do some. You can do it with your pictures. You can write in words on classifying triangles by sides, then by angles. All right. What would you say is the case for? How would you classify a triangle by its sides? What would you say it's classifying it by your angles? You and your buddy talk. I'm going to give you 2 minutes on my clock. If you were to describe that to somebody that never knew anything about triangles, how would you describe that to somebody? Go. Feel free to take that. Sorry. Might be. We're going to classify it by sides. Let's kind of go around here. Start there in the back corner. James, Julia, and Carter, what would you guys say for about triangle by sides? Scalene.
No equal sides.
Yeah, that's what I'm looking for. No equal sides. All sides are different lengths, right? Now, when we say that, no equal sides, or all sides are different, you could do that. You could put it in a picture. If you're put into a picture, we need to use our tick marks, and our tick marks by using 3 different tick marks, right? Okay, coming up to Spencer and Patrick. When you say isosceles, what did you guys say for isosceles?
2 sides are equal.
Okay, now I'm gonna put in one little extra word there. At least 2 sides are congruent. Sounds good. And same deal with that picture. We could have done our picture. And if I do my picture, I'm going to go ahead and use my single tick marks like we've done there. And then since that second side is not, I'll use my double tick marks right there. Okay, walking around here. Brianna and Nevaeh, what you guys got for what's the next one? Equilateral?
We didn't get that much.
You didn't get that far? Okay. Okay, what did you get for regular then? So what did you get for equilateral now? There we go. So equilateral and equilateral is all sides are congruent. So then our picture for that one is something like that. We use our nice tick marks. All the tick marks are the same. And what a regular is where all sides are also equal. And I saw, I think maybe it was on, it was on Chloe's here and Eva's. Chloe had drawn an arrow, kind of going back to that one. So regular is all sides are congruent. And I'm going to throw in one more thing here. All angles are equal. So regular is a combination of those two right there. A regular is the equilateral and equiangular. So let's drop it down to the equiangular real quick. And we just took care of the equiangular. The equiangular is all angles are congruent. Okay? All right. All angles are congruent. All right, let's walk backwards here. Acute. Caden, Sam, Nate, acute triangle. What did you say for an acute?
Less than 90.
Less than 90. Angles less than 90. And that one's maybe a little hard to say draw a picture of, so we'll just leave it at that. Right angle. Eva, guys, what do you guys have for that?
Has 190 degrees.
Thank you for saying 1. We can only have exactly 190-degree angle. Exactly 190-degree angle. Okay, because you can't have more than 1. And then coming next door there, Sydney and Faye, what would you say for the obtuse?
More than 90.
How many angles can be more than 90?
1.
Just 1. Thank you. Same thing. Exactly 1 angle that is what? More than 90 degrees. Okay? So with that now, take now another quick minute with your buddy. If you haven't done so yet, answer off number 4. Check all that apply based off of that. Okay? Oh, sorry, you guys had said isosceles were 2 sides that are congruent. And with that, equilateral is a special case of isosceles. It just so happens that all three sides are congruent, right? So with equilateral, it's a special case of isosceles. So we will go ahead and check the isosceles then, because we have at least two sides that are congruent, right? It just so happens then we got a third side. We can then also mark equilateral. So we are going to go ahead and mark isosceles as well on that one. And if we had regular up there, we would mark regular because regular is equilateral equiangular. Correct. Okay, last one. I think I've gone through other groups. So let's just maybe shout it out. Acute. Okay, so 50-50, I got to find that angle. It's 80. 100, 180 degrees. Yep, that's an 80 degree, so that does make sense. They're all still less than 90. What else do we got? Isosceles, 50-50. That implies the opposite angles are congruent. So we have isosceles. Is that it? Yepers? I think so. What did I tell you about yepers? Okay.
What did you say?
I know, it is Michael's got jammed off his boat. Even what's up. Okay. All right, let's keep talking about isosceles. I say yes all the time.
Oh.
All right, let's keep talking about isosceles. Now we talked about isosceles a little bit way back when. Let's go break through that again. Those two sides that are congruent in the isosceles. Typically, we don't say anything about the legs of a triangle unless it's a right triangle. But in isosceles, the two congruent legs, the two congruent sides, we do call those the legs. The third side that is not congruent, we call that the, yes, we do call that, I think you said the base. Now, the three angles, they do get actually a couple specific names. The two angles that are congruent, we call those the base angles. Okay. And then we called the one up top there where we included between the two legs. Anybody remember we called that angle between the two legs? We hadn't called it quite a bit. That's a nice one. We call that the vertex angle. Okay. So in the right triangle, we have obviously specific parts, the hypotenuse and the two legs. In the isosceles, we do also have some special things going on there. Scalene, nothing special there. We don't have legs or anything like that going. Well, I should say that scalene. Scalene could be in a right triangle. So we do have that. All right. So let's go ahead and do that then to the side. Let's take that, being what's being described, and let's go through and find it out. The measure of one base angle is, an isosceles is 23. Find me the measure of the other two angles. So we got, again, it's going back to knowing about that vocabulary. If you don't know the vocabulary, you're kind of stuck. So with it being an isosceles triangle, probably most of our pictures of an isosceles triangle go to what's being described there. But where you put that 23 does make a difference. As it's being described, where's your 23 going? It's a base angle, so we gotta know again what that base angle is. That's one of the bottom two angles, right? Now with that being 23, what do we got for the other two measurements then? You guys got your calculators. Other base angle's 23, and what's my other measure? 120 what? 134? Okay, so Zariah said that, and then Zariah said 134. Okay, that's a vertex angle. All right, let's walk it through here. If two angles of a triangle are congruent, then the sides opposite those are congruent. We've already kind of talked about that. So draw me out a picture and tell me what's the length of BC, or if you can visualize that in your head. Cool, great. What's that happening there? Okay. In triangle ABC, measure A is congruent to measure B. Now, when they tell you the measure of angle A is congruent to measure B in that specific triangle, what type of triangle do we just create? Yeah, they didn't tell you it's isosceles. But by them telling you A is congruent to B, or A is equal to B, either way, that was code for you now have an isosceles triangle there. So sketch out the picture that's being described, and when they told you A is equal to B, again, I don't care what triangle you draw out. Most people probably draw out regular triangles, unless it says specifically a right triangle. But most people probably draw out regular triangles. A, B, C. Again, however you want to label it, I don't really care. But when they say A is equal to B, mark it up. And what we've created now is, as Brianna said, this is now an isosceles triangle. AC is 12. Now, based off those markings, go put those tick marks on there. What is equal to what? What is the length of BC? BC is what? 12. Angle A is opposite BC. That's going to be congruent to angle B is opposite what? AC. So those are congruent. It's an isosceles triangle. So that's going to be a length of 12 units. Okay? All right. I'm going to give you another minute working with your buddy. Take number 7. I'd like you to try to answer out number 7 there. Go. All right. Let's try to finish this last one here probably. ABCB. Can we say AB is congruent to CB? Yeah. Now those are part of the big triangle, right? A, B, and C. Now, before I go and mark those as congruent, I got to have something that tells me that they would be congruent. What tells me in that picture that they are congruent, Carter? The angles are A and C are congruent, right? That is given to us, and because that's given to us, since the angles are congruent, that implies that the sides opposite those angles had to be congruent. So that is true. So we can officially then go and say those sides opposite those angles are congruent. So that first statement is true. Okay, then angle A, is that congruent to angle DEA? And trace out DEA, that would be right here. Can we say that? I heard Eric saying true as well. So the reason why that's happening is I've got these smaller tick marks right here, and these tick marks in that smaller triangle. If the sides of that triangle are congruent, what's that imply? The angles opposite those sides are congruent then as well. So true and true. Okay? All right, we'll continue on these notes tomorrow. We'll wrap up